Hi, my name is Dean, and last year I've built a personal code companion that helps me write better code. I'd like to take you on the journey that I've been through learning some internal Python mechanisms that helped me build this tool. And I'd like to start with this guy. This is Clippy, and if you were born before the year 2000, you probably remember that guy. He's not remembered very fondly. He tried to help you with functions in Office products. It was not a great product, but it was based on a great idea that maybe with the knowledge about user experience that we have today in 2021, we can try and ask ourselves, can we build this kind of tool for Python and for programming? And let's start with the use case, basically. So this is me, Dean, and this is my friend Belle, and we like bird watching. So we are going to the park, and we start looking around for birds. And as you can see, at each timestamp we've seen a bird, we write the type of bird and the time. So at 2 o'clock with 39 seconds, we've seen a sparrow, then a hoopoe. We've seen some wagtails and some myna birds. But this is not very helpful. The thing we wanted to see when we got home is this. At each hour, we wanted to see how many birds of which type we've seen along the way. So, for example, between the hour 3 and 4, we've seen 17 mynas, 25 sparrows, and so forth. And now we have the tool called pandas. And here in PyData, I guess all of you know that tool. And we want to use pandas to get from this to this. So I think you need to know about Belle. She's very smart, she's very talented, and she's hardworking. I have one advantage over Belle. I'm not as smart, not as talented, I'm not as hardworking, but I'm more experienced than Belle. So Belle, when she gets a task, she gets it done. The thing is, with pandas, there are many ways to get things done. And sometimes you may use a way that's not as good as some more experienced person would use. For example, Belle does this more than 10 lines of code. She does a pivot table. She reindexes some things many times. She creates date indexes. She's doing a lot of things. And she gets the job done. But then I come to the task, and with 5 lines of pandas code, I get the same thing done. Question is, why do you need me in this process, right? What if there was some kind of Clippy character that would tell Belle, hey, I'm seeing that you're trying to doing some group by on times. Do you know the method resample? Have you heard of it? So if we see a column named hour, so this is pretty simple logic, right? And maybe Clippy could know about it. So a little bit about me. My name is Dean. I'm married to Inbal, and I have one daughter named Stav, which I love very much. I work for SentinelOne. It's a cybersecurity company, and we use modern tools like machine learning and AI to attack old problems like antivirus and modern problems like detection and dynamic response to cybersecurity events. I'm also part of Data Hack. We arrange events related to data, mostly in Python around Israel. And I also created the package dovpanda. This is a personal code companion specifically for pandas. But today we won't talk a lot about dovpanda. We're going to talk about the engine behind it. What we want to do is basically take every method in pandas or in any other function and try to hook upon it in order to give the user messages before the method is actually executed. And the first thing you need to know is that in Python, everything is an object. And what do I mean by that? So we can define a function, my function. It takes an x and returns x plus 5. We could also say f equals my function. And when we do f of 5, it returns 10, as if f was my function. And the next thing we can do is we can say my function is the integer 1. So now when we run my function over 5, we won't get 10, we will see an error because you can't call an integer. So now the function that we've written is no longer called my function, it is called f, because the function itself is an object and it's just assigned different names. We can see that if we say f of 5, it is still 10. But we should handle this with care, because even built-in methods are objects. So we can say len, the built-in method len, equals 5. And now when we say what's the len of Israel, we will still get an error because len now is an integer. So let's learn how we hook over a function. So let's take the original len. We say original len equals len. Now we saved len in the side. And now we can define a function called other len, which takes an object. And first of all, it prints a message. It says len works on lists and strings, but will not work on ints and floats. And now it returns the original len of the object. What we're left with is doing len equals other len. And once we do len of PyCon, we can see that len works on lists and strings and will not work on ints and floats. And what's nice about it, because we've written the message before we are running the original function, we can ask what's the len of 5, and we can see that we got the error. The object of type int has no len, but maybe that message could be not very informative if you're not experienced in Python, but we came before and we said len works on lists and strings, will not work on ints and float. That's a more informative message for the user. Let's take another example. So now we can, from the math module, import costs and pi. And we can say original cost equals the cost, and the original and other cost says some message. Cost works in radians, not degrees. And then it returns the original. Now when we say cosine of pi, it says cosine works in radians, not degrees, and it gives the correct answer. But then we continue with the code, and many minutes later and many lines of code later, we are doing this. We say original cost equals cost. Now we have another message that we want to say. We say cost is a float between -1 and 1. And we say cost is the other cost, and we ask what's the cosine of pi. But the thing is, we get a recursion error. Why is that? Because we've already had a thing that hooked upon the cosine function. So now it's trying to hook upon it again, and it always, when it comes to calling the original function, it's not calling the original function, it calls the first function and just recursively doing the first other function again and again. So what can we do? We can keep a ledger. So I'm Dean, I'm sitting there with my book, keeping a ledger of all the functions we hooked upon. And Belle wants to write some hooking functions, so she asks me, hey Dean, did I hook on cosine already? And I say, yep. So she says, okay, I'll use it again for my additional hooking function. But then she asks me, hey Dean, did I hook on sine? And I say, nope. So she says, okay, I'm now going to hook upon that. And please keep track of this copy. This is the original sine. So now we can get a dict, and you say from math import cosine, sine, and pi. And we can create this ledger. The ledger equals, and now we'll take the name of the function as the key, and the function itself as the value inside the dictionary. When you try to see ledger, we see that cosine has the built-in function for cosine, and sine has the built-in function for sine. And now we can have a function that when we try to call the original function and we say the name in a string, we just return the function from the ledger. So if we say the original function of cosine, we get the built-in function. So now it's easier because Belle wants to write original cosine is the original function of cosine. And she writes some message and returns the original cosine. She's doing the hooking thing. We're doing the cosine equals the other cosine. And she gets this message. Great. Now I want to write a new message. So I'm doing the same. The thing is that now mine works because when I asked for the original function of cosine, I didn't take the one that Belle already hooked upon. I'm taking the original one. So now all we have to do is keep building a ledger, build a ledger of all functions inside the math module, right? We can do this 6 function, but the thing is there are many more functions in the math ledger, in the math module. So we can see that this is not the best, right? It's manual, first of all. It's bloating the code, right? Because if you're building a ledger in the beginning of the code, you can take many lines of just building a dictionary. It also requires foresight because we may not use all the functions, and we may try to put some functions in the ledger that the user will want to use. So we need to find a better way. And this better way comes with the get attribute and set attributes methods in Python. What is the get attribute? So instead of calling functions from modules, we can get the function as a string input. What do I mean by that? We can get, if we want to, let's say, get a function from a CLI, right? So if I'm building a CLI and I want to get the cosine function, I'm passing Python the string cos, and I just want Python to understand that. How do I do it? I'm getting the attribute cosine from math. And let's say I want to use to get pi, I'm doing the same thing. My pi equals get attribute from math, the function called pi. And you can see that if we call my cos over my pi, it gives us the correct answer because those are the built-in functions in Python. You can use it for many things, and we are using it for one use case. What's set attribute? It's pretty similar, just now we have 3 things in the signature, so we can set attribute of math. Let's say we call something almost pi, and the value is 3.14. What can we do now? Because if we say math.almost pi, Python gives us the correct answer, so we can actually inject methods and inject properties and attributes into objects. You can inject it into modules or into classes, and more things you can think of. What can we do now? We can reimagine the ledger. So let's start the ledger as an empty dictionary. And now when we call original function in the and with the name, we ask the ledger, if name not in your keys, then set it in your keys. Ledger in the location name, get attribute from math, the name. And eventually we return the ledger name. If it was in the ledger, we didn't assign to it. And if it was, we did. And then eventually we return the function in the ledger. So now when we have original func of the word seal, we get the built-in function seal. And also when we check ledger, we can see that we've written seal inside. So let's try this. We do func name equals seal, and we define a hook function, hook for seal. It prints seal accepts float, but returns int. So now we can say the original is the original func of func name, and hook func is the hook for seal. Now what can we do? We can define a function that is the other function, and now it's a more robust function because it accepts args and quargs. It runs the hook function, and then it returns the original function. What are we left to do? We need to set attribute on the math module with the function name, so the original function name, but we're assigning it the other function. Why can we do this? Because again, everything is an object, so we can assign values to names, but you can also assign functions to names. And let's check this out. Math.seal of 4.5. It says seal accepts float, but returns int, and then it gives us the answer. The answer is 5. Let's leave this aside for a minute, and let's talk a bit about decorators. I'm sure all of you know about decorators. The thing with decorators is that if you don't use them regularly, you tend to forget how to use them and how to write them. And I want to show my way of thinking about decorators. And I find it that once I've seen many ways people think about decorators, it's simpler to understand because the more point of views I see, I can understand better how they work. So let's get the intro into decorators, let's define a function called add. It takes an x and y, and it returns x plus y. Let's define another function. It prints args of a function that it gets, right? Because in Python, everything is an object. Functions accept functions. So inside the print args function, we define another function called inner. It gets x and y, and it prints the values of x and y. Then it returns the original function that we've given it. And let's check it out. So we can say f equals to print args of add. And when we say f of 2 and 4, first of all, it prints the message. X is equal to 2, y is equal to 4. And eventually it returns, Python returns the answer, which is 6. Remember, everything in Python is an object. Why is this important? So instead of saying f equals print args of add, we can say add equals print args of add. So now when we say add of 3 and 5, again we get the message x is equal to 3 and y is equal to 5. And we get the answer 8. The thing is, now the original add doesn't exist. But that's okay, because we never wanted it to exist. We always wanted this functionality. And this is a common pattern in Python. Every time we're doing f equals a wrapper of f, we can just replace it with a decorator. So now we can say at print args and then define the function. So now let's define sub of x and y. We return x minus y. We can see that sub of 10 and 7, it prints the values and then returns the answer, which is 3, which is correct. It doesn't change the behavior of the original function. It just prints to the screen the thing we wanted. So now let's combine those two. We had the original is the original func, and the hook func is a thing we define, which in this specific case is the hook for seal. We can define other function which accepts args and quarks, and this is the same thing we've done before. But now we can refactor that, and we can say add hook is a function that accepts a function name. Then it keeps in the side the original function. It writes this to the ledger because it uses the original func method. Now we defined other function, which takes the hook function and then runs the hook function and then runs the original function. And in the end, it sets the attribute to the original module, which is math, and eventually returns the function. How does it work? Now we can do add hook of floor. Now we define hook for floor takes args and quarks, and which is robust because we don't know what floor takes. We just want to print this message. Floor on negative numbers may be confusing. What do we mean by that? Now the user runs math.floor of minus 4.2, and it says floor on negative numbers may be confusing, and the user gets minus 5. And that's the correct mathematical answer, although some people may expect minus 4. So now we can just build our personal code companion for the math module. For example, for the seal, it prints seal accepts floats but returns ints. For the sine, it says sine is in radians, and so on and so forth for the cosine and every function inside the math module. And now I want to talk about the inspect module. This is a built-in Python module you can just import. And why do we need this? Because now we don't want to just write generic messages. We want to see what the user gave to the function and maybe check out what can we tell the user based on what they are doing. So first of all, why do we need inspect? Because we need consistency. If we have the function write args that accepts args and quarks, and first of all it prints args, then it prints quarks, and eventually runs the function. So if we do the write args for add, and add accepts x, y, and z, but z has a default value of 3. It eventually returns x plus y plus z. So we now can we now say add of 1 to 3 and write args writes 1 to 3, the arguments, and an empty dict for the quarks? What if we say add of 1, 2, and z equals 3? Well, now it says 1 and 2 as the args, and the dictionary of z, which equals to 3, in the quarks. And eventually, add of 1 and 2 gives us the same answer because z has a default value. But now we don't see it not in the args and not in the quarks. But we wanted to see the value of z because maybe we will eventually have a message that requires z to exist. What do we do here? So now we import the inspect module. And the inspect module has a method called signature. And we can see the signature of add, and then we can bind to it the values 1, 2, 3. And when we view signature, we can see that it gets a class called bound arguments that we can turn into a dict. And now it says a dict gives us a dictionary with x as 1, y as 2, and z as 3. Why is that good for us? Because now we can do the same thing, but now we can say bind of 1, 2, and z equals 3. Well, if we look for the dict of sig.arguments, we will get the same dictionary. And eventually, if we only bind 1 and 2, well, now we get only x and y inside the dictionary, which could be scary unless we add the method called apply defaults. So now we have the signature, we are applying the defaults, and now when we ask for the dictionary of sig.arguments, we eventually get the same dictionary. And why is this good for us? Because now in the inner function, the one that we're trying to help us write the hooking function, we can bind the args and the quarks, we can apply the defaults, and eventually pass to the hook function the args dict. But why? Why should we do it? So let's look at this use case. The function pow from the math module takes the pow of x and y, takes x to the power of y. And now, because we know the values of y, which exists in args dict in the location y, we can say that if y is between 0 and 1, we can tell the user taking fractional power is like taking the inverse root, right? For example, the power of 1 over 2 is the second root of what we're working upon. And also we can say that if x is the base of the power is less than 0, we can say base is less than 0. It may not work on fractional powers, right? Because the square root of, let's say, -4 does not exist. It's not defined mathematically. Let's see what happens. So math.pow of 2 and 4 is 16. We're not writing anything to the screen. That's what we wanted to happen. But now if we say math.pow of 16 and 1.5, it says taking the fractional power is like taking the inverse root, and correctly we get the answer 4. And now when we say the power of -4, the square root of -4, or -4 to the power of 1 of 0.5, it says first of all the first message because y is between 0 and 1, and then it says the second message, base is less than 0, it may not work on fractional powers. And what do we get from Python? We get value error, math domain error. And why was this good? Because if I'm not maybe experienced, maybe it's been 10 years since my last calculus lesson, I get math domain error and I do not understand why this is. So I'm looking around the internet, I'm Googling for the answer, and I'm not sure what I'm getting. But if I could Google or copy paste into Google, maybe ask a friend, the sentence that say base is less than 0, it may not work on fractional powers, I will probably get a more informative message of understanding the math domain error. The last technical things we're going to talk about is the abstract syntax tree. And we're going to see why is this good. And first of all, we want to see how Python reads code. And Python reads code as a tree structure. Every statement and each moving part is a node in the tree. So let's take a simple code, x equals 4. What is this? This is the module. Now it has Python sees this because of the equals. Python sees this is an assign operation. What does assign have? Assign has two things: the name that we want to assign to, and the value. The name is also called the target. Eventually, it's doing a store operation. And again, if we have two lines in this code, that's fine, because under the module, we can see we have two subtrees, one for the assign and one for the expression that says x plus 3. You can see a bit how this works. So we can import the AST. Now this is the AST module in Python. We are using Python built-in tools to read Python code. So this is the superpowers that we now have as experienced Python developers. We can use Python to change and see Python behavior itself. So we have a variable called node, and we ask it to parse. ast.parse x equals to 4. And let's see what Python sees. So it sees the body. At the location 0, it says this is ast.assign object. And now, if we take the body at location 0, we see the targets. We can see in the right that we have in the targets, we have a name with the ID x. And if we access targets.id, we get the name x. And if we look at the value, we get almost the same thing, but in value, the value is called n. So value.n equals to 4. So now we have a way to see the abstract syntax tree inside the code. And why is this good? So let's go back to pandas again, for example. And let's see, we import pandas as PD, and now s equals to pd.series 132. And what can we do when you get 132? We first of all sort the values. So s.sort values gives us 1, 2, 3. But if we now look at s, we see that it did not change the object. It just returned a view into the object, which is sorted. So what can we do? We can say s.sort values and say in place equals true. But now when we print s, we get none, because pandas have two ways of operating. We can change the object in place, but then it returns none, or we can attain a view and then assign the view to a new variable, which is sometimes the same name. So this was not a wanted behavior. We either wanted to run with in place equals false, or we wanted to run without s equals. So now we can tell the user the exact same thing I just did, but we need a way to see if this was an assign operation or just an expression. And that's fine, because now we have the tools. So let's add hook upon pd.series.sort values. Now we get the first 3 lines are for getting the code, and now we can say is instance of node the ast.assign. If it is, then get the in place. In place is the argument in place from the args dict, the ones that we've seen in the inspect part of the talk. And now we can ask Python if in place, or if in place equals true, then print. Careful, you're assigning none. And I've wasted hours of my life before I became more experienced in pandas in order to understand that I'm assigning none to my values because of this in place equals true. If this existed when I was beginning with pandas, it would have saved me hours of my life. Let's see how this works. S equals the series. Now we do s equals sort values. It's fine because we're not assigning in place. But in the final line, we say s equals s.sort values in place equals true. It changes the object, but it tells us, careful, you're assigning none. So now if I'm working, let's say in a notebook environment, this is more for a interactive code, not for production, let's say. It says, careful, you're assigning none. I will now go back to my code and change it accordingly. And this concludes the technical part of this talk. So we learned about the inspect module, the AST. We've seen another approach to how we approach decorators. We've learned about set attribute, get attributes, and we basically seen how we can hook function who can hook messages and all functionality upon other Python functions, almost all of them. Some of them are protected, but that's not for today. But what's the motivation? So let's see a few examples. First of all, I have dovpanda. Dovpanda does exactly what we've seen here, specifically for the pandas package. So in this talk, we've mostly talked about how are we hooking upon the math module, but we can hook upon any built-in modules or installed modules, and dovpanda works on pandas. What we can see, for example, dovpanda works if we import it. We only need to import dovpanda. Dovpanda is short for directions over panda, but all of you Hebrew speakers here, I hope you get the joke. We import pandas as PD, and then we import dovpanda, and we can just accept dovpanda to start working. So if we define a data frame with some strings, some numbers, and some time objects, and we ask, for example, so df hour is we want to tell pandas this is a time object, and then we group by hour and take the sum of b are ints. So dovpanda says it seems like you are grouping by a column named hour. Consider setting the time column as index and then use df.resample. This blew my mind, by the way, when I've learned for the first time. Resample for time objects is amazing, and it replaces group by in a much better way. And this works perfectly. But the thing is that because we hooked upon a function with another function, so the hooking function doesn't have to be just prints to the screen. We can do anything. For example, we can create another class that displays HTML, and inside this HTML we can format our helping mechanism to show nicely in Jupyter Notebook. So dovpanda does that. But now more motivation is that I've built dovpanda, but I encourage everyone, if you want, you can write dovsklearn, dovpytorch, dovrequest, dovdjango, whichever place you're coming from in Python. You can write a personal code companion for you and for people less experienced than you. Another use case, so let's say me and Belle, we used to work, we've been a team of 2, and we know how to work with each other, and we are very experienced with the mechanisms we have in our company, and we've built this team complex logic function. And now we have new guy. New guy joined the team. He's also very smart, very talented, very hardworking, but again, he's not experienced, and he's specifically not experienced in the proprietary code in our company. And this complex logic takes a lot of arguments. Let's say it takes a classifier from the sklearn module, but it also takes protocol. And the thing is that many classifiers can work with many protocols, but some of them cannot work well with the others. So for example, if new guy chooses none as the protocol, it automatically chooses ghost21. Maybe it didn't know that. And ghost21 does not work with the decision tree classifier. Now we tell new guy, for further information, go to the team wiki. Why is this good for us? We could have written all of that in the documentation. The thing is, we have many classifiers and many protocols, and maybe specifying for each of them which one does not work with the other as well could cause the documentation to be too long for anyone to actually read. So if they get this error, they can actually click the link and see the Confluence page, the wiki page for the team, and then read more, we have a wider knowledge base of the team inside the wiki. What else can we do? We can do white hat security. For example, I'm from the SQL Alchemy module. I'm importing create engine, and the first thing I need is the connection string to my database. So I'm doing PSQL Dean strong password. Strong password is my password, so that's a problem. We wouldn't want to write strong password into, let's say, a public repo, for example. So we can do some personal code companion that would write, warning, you provided a database string containing password. Careful when pushing to public repos. And we can do the same with Bottle3. We can create resource with our access key ID and the access key secret. And again, we would want some personal code companion to tell us you've written, please notice that you're doing this and do not push this to public repo. Another thing we can do context manager hooks. So let's say we have a robust we define a robust logger that connects to DB of logs. Then it hooks over some functions that we want. Then it yields, so it's waiting for the user, and eventually it cancels the hook. What does it do? I can say with robust logger, let's run function 1, function 2. It writes to some database that the user used function 1 and function 2. But eventually, when the user wants to close robust logger, it will not write those to the database. Let's say for testing purposes, we wouldn't want this to be written to the logging database. So let's sum this up. Python is superpowers, and we can leverage Python to change Python behavior itself. One of the ways we've seen is hooking on a function with every other function, and this will help us write personal code companions, for example. And also the first and currently only example for this personal code companion is dovpanda. It's my package. I like it. I think it's awesome, and I encourage you also to use this. Those are my social profiles. You are welcome to friend me. You are welcome to ask me specifically about dovpanda or anything else in this talk. And now we have a time for questions, so hit me up in the chat. And thank you very much.